Okay, now we want to see how to sketch the graph of hyperbolic functions 2.2.2. So, in the previous topic, we can see that the hyperbolic functions depends on the values of e power of x and e power of negative x. So, the graph of hyperbolic functions are the combination of the exponential graph. So we look at the first graph, which is sin x. Okay class, when you want to plot the sin x, you can substitute the value of x and then you will get the value of y here. Okay, let's say this is negative 3, you get negative 10. So negative 3, negative 10 here, right? Okay, and then negative 2, you get negative 3.6. Okay, negative 3.6. So 3.6 is here. Okay, and then negative 1, you get negative 1. Okay, negative 1, you get negative 1. Negative 1, you get negative 1 here. Okay, and then you look at 0, you get 0 here. And then 1, you get 1.1. Okay, here. And then 2, you get 3.6. Okay, so here, and then last 3 you get 10. Okay, so you can sketch the graph like this. Okay. Okay, for graph of sin x, you remember the definition of sin x is sin x equal to e power of x minus e power of negative x divided by 2. And then we spread this e power of x divided by 2 minus e power of negative x divided by 2. So you plot this exponential, okay, function, this one and this one. Okay, we plot this because we want to look at how this graph of sin x become like this. Okay, so for your information, in this syllabus, what you have to do is you try to remember how to plot this graph. In this video, I show you how this graph of sin x is become like this. But in your case, what you have to do is you can directly sketch this graph. Okay class, so I will show you how to sketch the graph of sin x by using the graph of exponential graph. Okay, so first we want to see that what happened is when we plot e power of x divided by 2. So this one is e power of x divided by 2. Okay, now we try to sketch. Okay, so you will get the graph like this. Okay, this one is e power of x divided by 2. You see the cross section is at y equal to 1 over 2 here. Okay, and then the graph is not attached to y equal to 0. Okay, next, we want to look what happened if we plot negative e power of negative x divided by 2. Okay class, when we plot negative e power of negative x divided by 2, we will get, okay, so we will get like this. The cross section when x equal to 0, okay, you substitute x equal to 0 here, you will get, okay, you substitute x equal to 0. So you will get negative 1 over 2. So negative 1, okay, y equal to negative 1 over 2 is here. So the cross section when x equal to 0 is at y equal to negative 1 over 2. So you can substitute the value. Let's say x equal to 2. What happened? Okay, if you substitute x equal to 2, so you will get negative 0.06 something. Okay, so you will get negative 0.06 something. So here, and then let's say x equal to negative 1. You get negative 1.3 something. Okay, negative 1, you get negative 1 point something, and then you can try so on. So you know that the value is this one, and then here, and then here. So you can plot the graph. Okay, so you know that this one is exponential function, so the graph is like this. Okay class, now we try to combine the graph of e power of x divided by 2 and graph negative e power of negative x divided by 2. Okay, so in my programming I write ex1, exp1, exp2, so you will get like this. So this is e power of x divided by 2. Okay, when we write divide by 2, make sure you know the cross section is 1/2, and this one is y equal to negative e power of negative x divided by 2, and then the cross section is negative 1/2. So when we get two graph, what we can do is we will get the graph of sin x. So this is the way how the graph of sin x is come. Okay, but you can sketch directly using the point of x. This is the explanation, okay, how the graph of sin x become like that. Okay, now this is the combination of these two exponential graph. Okay, I changed the x-axis and y-axis. Okay, x-axis from negative 4 to 4, and then y from negative 10 to 10. Okay, this one is similar like in your note. Okay, and then you see this graph, you have these two graph. Okay, from this graph you will get the sin x. Okay, this is sin x, so you will get like this. Okay, the magenta color, the pink color is sin x. So the graph of sin x is come from the exponential. Okay, you see from negative 10 here, move until to 10, and then the shape is like this. The red color is e power of x divided by 2, and then the blue color is negative e power of negative x divided by 2, and then the combination of these two exponential graph, you will get the sin x like this. Okay class, from the graph we see that when we substitute x equal to 0, we get sin 0 equal to 0 here. Okay, and then the domain is all real number. Okay, the domain is x-axis, so all real number, and then the curve is symmetrical about the origin. Okay, so when you sketch this one, you will get like this. So this one we call the graph is symmetrical about the origin, and then the last one is sin negative x is equal to negative sin x. Okay, this one similar like sin negative x equal to negative sin x. Similar. Okay, now we want to plot the graph of hyperbolic tangent x. Okay, let us see if x equal to negative 4. Okay, so y is approach to negative 1. So the point is here. If x equal to negative 3, we get negative 0.995. Okay, so here, and then negative 2, okay, negative 0.96 something. Okay, how about 0? So we get 0 here, and then okay, when x equal to 2, we get 0.96. Okay, so here, and then how about 4? We get 0.999. Okay, so approach to 1. Alright, so you will get the graph like this. When we talk about hyperbolic tangent x equal to e power of x minus e power of negative x divided by e power of x plus e power of negative x. So when x larger, okay, so we sketch e power of x. So we get like this. So this is e power of x, and then this one is e power of negative x. So when x is larger, we will get e power of negative x approach to 0, okay, when x is larger. Okay, so we see that e power of negative x approach to 0. Okay, so we will get hyperbolic tangent x approach to ex minus 0 divided by ex plus 0. So we will get 1 here. And then if x smaller, so x smaller, so we can see that e power of x approach to 0 here. So e power of x approach to 0. So hyperbolic tangent x approach to 0 minus e power of negative x divided by 0 plus e power of negative x. So this one you get 1. So we can see that tangent x approach to plus minus 1. So this is y equal to 1, and then this is y equal to negative 1. So meaning that the graph of tangent x approach to y equal to 1 and then y equal to negative 1. Okay, you see here class, tangent 0 equal to 0. Tangent x always lies between y equal to negative 1 and 1. And then tangent negative x is equal to negative tangent x. Okay, this one same like tan negative x equal to negative tangent x. Okay, then it has horizontal asymptotes y equal to plus minus 1. Okay, now we want to look at the graph which is y equal to CHAP x, okay, or hyperbolic secant x. Okay, so you can look at here, okay, this is y equal to 1 when x equal to 0. And then when x equal to negative 4 and 4, okay, y approach to 0, okay. So the domain is all real number. Okay, and then range is 0 less than y less than and equal to 1. Okay, this is graph for hyperbolic cosecant x, which is called CHAP x. Okay, so you can find what is domain here and then what is range here. Okay, you refer this graph, you can know what is domain and range. Okay, you can try this. Okay, last graph is y equal to hyperbolic cotangent x. Y equal to cos x. Okay, what is range for this graph? Okay, you see here y approach to 1 and above, and then this one y approach to negative 1 and below. So can you guess the range of this graph? And then how about domain? Okay, we look at the domain. You see here the graph, okay, approach to x equal to 0, right? So meaning that x cannot be equal to 0. Okay, so x can be any real number, but x cannot be equal to 0. So the domain is x cannot be equal to 0. Okay class, I hope that you all can sketch all the graph of hyperbolic functions, and please try to practice more and then find what is domain, what is the range. Okay,